Welcome to today's explainer. We're jumping right into an absolute grease-covered battle, literally man versus machine, as we completely tear down a rusted industrial behemoth. Think of this as extreme mechanical archaeology. We are taking a massive, totally forgotten piece of engineering and, well, dragging it kicking and screaming back into the land of the living. It's going to be a wild journey filled with fire, leverage, and a whole lot of sheer human stubbornness. It's untakeoutable. That single hilarious phrase perfectly captures the sheer frustration we're dealing with today. When we're trying to restore heavy machinery that's been left out to the elements, you aren't just turning wrenches anymore. You are fighting molecular bonds. Rust isn't just surface damage, right? It's basically nature's welding, fusing solid steel components together like they were cast as one single piece. And that feeling of absolute impossibility? Yeah. That sets the stage for every single battle or restore Alec faces in this teardown. So why exactly is this so impossible? Well, just look at this number. 67 years. That's how long it's been since these internal bolts and pins were last touched by human hands. 67 years. And to make matters worse, for the last 20 of those years, this multi-ton machine was quite literally sitting abandoned in a damp bush. 2 decades of rain, freezing, thawing, and expanding rust, it's turned what used to be a precisely engineered machine into a giant, solid block of oxidized iron. Okay, it's totally crucial to understand our mechanical adversary here. We aren't just talking about a simple hammer. This is a Massey ClearSpace 500-weight power hammer. It is a massive, self-contained marvel of 1950s Manchester engineering. Now, unlike other power hammers from back then that needed a massive external steam boiler or some giant separate air compressor, this beast, it generates its own internal pneumatic power. It literally compresses its own air in the back to drive a devastatingly powerful ram in the front. It's absolutely brilliant mid-century design, but all that complexity means we've got countless internal chambers, seals, and linkages that are now completely, hopelessly seized. Which brings us to Battle 1, freeing the seized linkages. Now, these linkages, they're basically the nervous system of the machine. If they don't move, the hammer is useless. And trying to free them brilliantly illustrates just how quickly this teardown turns into pure chaos. Because you don't just unscrew things here. Step 1, applying extreme oxy-fuel heat just to break the rust's death grip on the rod. Once it finally barely started to move, we hit Step 2, which meant blindly hammering away at a completely hidden, tapered pin deep in the dark recesses of the frame. You can practically hear the clanging and the frustration. And then, Step 3, the ultimate comedic tragedy. In a rare moment of triumph, the pin breaks free, only to immediately drop straight down into the machine's cavernous oil sump, meaning Alec has to go fishing in the murky depths. But getting into that sump actually revealed an even bigger and, frankly, much messier problem. Turns out, because this hammer was exposed to the rain for 20 solid years, the oil reservoir was completely flooded. So when the drain plug was finally pulled, it wasn't just old oil trickling out. Oh no. It was a massive separating geyser of foul water and sludgy oil that just rapidly overflowed the catch pans, pouring straight over our restorer's shoes and soaking right into his socks. Gross, right? It's a hilarious but super potent reminder that when you crack open a time capsule like this, you really never know what kind of nasty surprise is waiting inside. Let's take a quick detour for some modern upgrades, crafting a modern top die. So before tackling the next rested boss, the machine desperately needed some reinforcements. The hammer actually came with an enormous bottom die, but the top one was just completely missing. But instead of forging a replacement by hand, this is where modern technology steps in. A custom 3D model was sent out to PCBWay, and they CNC machined this gorgeous heavy-duty replacement die out of incredibly tough 4340 steel, hardened perfectly to 45 Rockwell. Honestly, it's such a beautiful, shiny contrast to all the rust we've been looking at. And it proves that you can absolutely use cutting-edge manufacturing to help bring a 1950s workhorse back to life. All right, back to the grime. Battle 2, removing the rear piston. Now we really have to dive into the belly of the beast. To understand why this rear cylinder matters so much, you gotta understand how this machine breathes. This rear assembly acts as the actual lungs of the hammer. A heavy forged connecting rod, driven by a crankshaft, forces this rear piston up and down. And this creates what the source wonderfully describes as a pushy-sucky action. That action generates the massive air pressure required to throw the front ram down onto the anvil. It's the absolute core of the hammer's self-contained power. But because it was left outside with its valves totally exposed, yeah, we have to assume the absolute worst about its internal condition. The whole thing has to come apart. But getting a grip on that massive piston led to a truly baffling twist of 1950s engineering. See, there's a threaded hole right on top of the piston, obviously meant for a lifting eye. Naturally, you'd assume it's a standard bolt thread, right? Well, when a 3/4-inch British standard Whitworth eye was threaded in and they pulled up with a forklift, pop. The threads instantly stripped out, which nearly caused a huge disaster. Why? Well, after some highly confusing inspection, it turns out those engineers in Manchester had actually tapped a 1/2-inch British standard pipe thread into the piston. I mean, who does that? Eventually, borrowing a neighbor's pipe threader to cobble together a custom lifting spigot saved the day. But man, it's exactly these bizarre, undocumented quirks of vintage machinery that turn these restorations into massive detective projects. And that detective work? That was really just the prelude to the physical grind, because extracting the connecting rod from the crankshaft became an agonizing day-long battle of escalating tactics, just to free a single castle nut. The progression here is staggering. Hour 1 involved making terrifyingly precarious cuts with an angle grinder, deep inside the oily bowels of the machine, just to sever a rusted split pin. By hour 2, they had to fabricate a custom tool, dubbed the Pin Pusher 3000, just to press the remaining metal out. And finally, by hour 3, after some brutal contortions, smashed thumbs, and relying on pure leverage, the magnificent 1950s forged connecting rod separated. Yep, that was an entire day's productivity spent on exactly 2 bolts. And that leads us to the final showdown. The final boss, battling the base plate bolts. So, to completely strip this machine for cleaning and painting, Alec had to do the unthinkable: separate the colossal upper standard from the massive base plate. To defeat 67 years of nature's rust welding on these enormous fasteners, he had to unleash a heavy-duty arsenal. I mean, you couldn't just grab a standard wrench for this. It required literally barbecuing the gigantic nuts with an oxy-fuel torch until they were glowing cherry red. Then out came the custom weaponry, a massive fabricated Franken wrench paired up with a giant Frankenbreaker bar. And even with all that heat and mechanical advantage, it took immense screaming physical cardio, literally pulling with every muscle and putting his spine on the line just to get even a millimeter of movement. But when that movement finally happened, oh, it was glorious. Alex summed it up perfectly. The fact that that bolt fell down means that I don't have to pound on it with a sledgehammer. After all the heating, the straining, the sweating, hearing the heavy clunk of that massive bolt dropping freely onto the concrete floor was like a symphony. It meant the structural integrity of the rust was finally broken. They were winning. 4. That is the total number of massive base plate bolts that were finally successfully defeated. But what's truly mind-blowing is what they found underneath. Once those huge bolts were pulled out, the shafts actually revealed clean, pristine, shiny, machined surfaces. Think about that. The factory seal was so tight that in nearly 70 decades, even sitting 20 of those years abandoned in a bush, not a single drop of water or molecule of oxygen had penetrated the middle of that joint. I mean, wow, it is just a stunning testament to the sheer quality of mid-century industrial manufacturing. So, as we wrap up this grueling teardown, it leaves us with a really inspiring thought. This Massey hammer was totally written off. It was rotting away, slowly being consumed by nature. And yet, beneath all that grime and those seized linkages, the incredible craftsmanship of the 1950s was just waiting to be uncovered by someone with enough heat, leverage, and downright stubbornness. It really begs the question, what other massive forgotten pieces of engineering history are out there right now, quietly rusting in the bushes, just waiting for someone brave enough to bring them back to life? Thanks so much for joining me for this explainer, and hey, keep your eyes open. There might just be some hidden history rusting away right in your